So this is question 25. We need to talk about the number of possible real zeros and turning points, and then determine all of the real zeros by factoring. So you can see I already started to factor this quartic polynomial. Before we even look at that, think about what we did in class today. If it's a fourth degree polynomial, that means that it can potentially have 1, 2, 3, 4 zeros. So the possible number of real zeros is 4. The turning points, if you just look at this sort of W-shaped graph, it has 1, 2, 3 turning points. Notice the turning points is always one less than the number of possible real zeros. So we could potentially have 4 real zeros and 3 turning points. That doesn't happen, however. When I factor this quartic polynomial, it's kind of factored like you would factor a quadratic. I know positive 7 times negative 3 equals negative 21. And I know that positive 7 plus negative 3 equals positive 4. So at this point, I can think of this first binomial, x squared plus 7, as having no real zeros, no real solutions, because I can't think of a number. When I square it, I get negative 7. Okay, I can actually think of a number, but it's imaginary, and we're talking about real zeros. So this has 2 non-real zeros. The one on the right, though, has 2 real zeros. If I think about solving this equation after setting it equal to 0, I'm left with x squared minus 3 equals 0, which means x squared equals positive 3, which means x will equal both positive or negative square root of 3. So those are the 2 real zeros. So if you look at a graph of this quartic polynomial on your Desmos or your graphing calculator, you're going to notice that it crosses the x-axis around 1.7 and negative 1.7, but it won't cross anywhere else.